Hello mathematicians, welcome to Maths with Matt. This is going to be another quick math video. Today we're going to look at binomial expansion with Pascal's triangle. So we're not going to go for a full-blown binomial expansion, but we're going to look how Pascal's triangle gives us coefficients of the expansions. Okay, so a binomial expansion. What is a binomial expansion? Well, a binomial is a expression with two terms. Bi means two. So a binomial will be of the form a plus b. And we're going to look at how to expand a plus b. So a plus b to the power of 0 is just equal to 1, because anything raised to the power of 0 is equal to 1. A plus b to the power of 1 would be equal to a plus b, because anything raised to the power of 1 is equal to itself. A plus b squared. Now we have to multiply out the bracket. I still have to write both brackets. So a plus b, a times a is equal to a squared. A times b is plus ab. B times a is plus ba, which is just ab. B squared plus b squared. Tidy that up, we get a squared plus 2ab plus b squared. A plus b cubed would be equal to a plus b multiplied by a plus b squared, which is a squared plus 2ab plus b squared. And that's going to be equal to we multiply 3 by the a first, a cubed plus 2a squared b plus ab squared. Now we multiply 3 by the b plus a squared b plus 2ab squared plus b cubed, and then we have to tidy up, so we've got a cubed plus 2a squared b, 2a squared b, but we've still got an a squared b there, so that makes 3a squared b, and then we've got a 2ab squared plus an ab squared, so that's plus 3ab squared plus b cubed. And we can also we can immediately see that a binomial raised to the power of 3 is becoming a little bit tricky to be able to multiply out. So just imagine having to do something like a plus b to the 7, and you wouldn't want to multiply that out by hand. This is where the binomial expansion comes in. And there's a few things we notice looking just at this a plus b to the power of 3. The first term is just a raised to the number. And then a reduces. A cubed becomes a squared, becomes just a, and becomes a to the 0, no a. Whilst b is to the power of 0 here, there's no b, but then b to the power of 1, b to the power of 2, b to the power of 3. So a is reducing in power whilst b is increasing in power. Well, that's really easy then. We should be able to write down a binomial for a plus b to the 7 relatively easy. That would be a to the 7, no b, plus a to the 6, b, plus a to the 5, b squared, plus a to the 4, b cubed, and we could keep going all the way up to b to the power of 7. Oh, that's a lot easier than multiplying out a plus b to the 7. We don't have the coefficients though. We don't have these values. And there's something else we can notice from our expansion. The coefficient of a plus b was just 1, the coefficient of ab to the 1 is 1, 1. The coefficient of a plus b squared is 1, 2, 1. And the coefficient of a plus b cubed is 1, 3, 3, 1. And I don't know if you noticed, this is Pascal's triangle. Pascal's triangle is constructed by writing 1, 1, 1, and then we add 1 and 1, we get 2, 1, 1, and then we add 1 and 2, we get 3, 1 and 2, we get 3, 1, 1, add 1 and 3, we get 4, 3 and 3, we get 6, 3 and 1, we get 4, 1, 1, add 1 and 4, we get 5, 10, 10, 5, 1, 1. And this is Pascal's triangle. And this is giving you the coefficients. The coefficients of a plus b to the 0 is this line, a plus b to the 1, a plus b squared, a plus b cubed, a plus b to the power of 4, a plus b to the power of 5. Well, okay, let's use Pascal's triangle to actually write out the expansion of a plus b to the power of 4 then. Well, a plus b to the power of 4, that would be the 1, 2, 3, 4, 5th row of Pascal's triangle. We have to add 1 to the power to find the row because we start at 0. Okay, so the first term will be a raised to the power, which is 4, b to the 0, coefficient is 1, plus we knock 1 off the power of a, we add 1 to the power of b, introduce the next coefficient, plus we knock 1 off the power of a, add 1 to the power of b, bring in the coefficient, then we knock 1 off the power of a, add 1 to the power of b, bring in the coefficient. Finally, we knock 1 off the power of a, we add 1 to the power of b, bring in the coefficient, and we find that the expansion of a plus b to the 4 would be a to the 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4. If you found this maths short useful, like and subscribe. We'll see you next time.